Uh, yeah, so what are the doubts you generally have? Like, yeah, Diptiman, you can go ahead.
Yeah, so let's say for the longest increasing subsequence,
Hmm.
so we can have a longest increasing subsequence.
Hmm.
That is one problem. Like we can do it in O n square, but now if we have to find the number of longest increasing subsequences in an array or a string, something like that,
Hmm.
that time I have seen ki like if there are two factors for a particular DP, that time it is difficult.
Got it. So,
Like
got it.
to come up with.
So basically,
Yeah.
most of you face problems when you have two-state DP. Okay, like there are two factors that you need to take care of when you are making the transition states. Okay, and like another problem that Tarun and Diptiman both talked about, like uh, making the relation, like first of all making the recursive relation and then converting that into a iterative one. Okay, so these are the two main challenges that people face, as far as I understood. Any other problem which people face? Base case is fine, like both of you told, or like many people told, that we can identify the base cases of the DP states. Okay. So apart from these two, like what any other specific problem which you face in DP? Like let's say if I give you the code, can are you being able to analyze the time and space complexity of the DP code? Like let's say if I give you the code, okay, can you analyze and tell me the time and space of that, of a DP solution? Hello.
Yes, most of the times, yes.
Okay, cool.
Yeah.
Cool. I think we will start. Okay. So let's start from the very first or the very basic thing. Okay. So what is DP? Okay. So DP is basically dynamic programming. So in the last session, or in the last, I would say, meet, we discussed about recursion, right? So in recursion, what we do, let's say we have a function fn with a particular variable x. Okay, so that function calls the same function again with a smaller variable, like let's say x minus 1, or let's say x by 2, something like that. Okay, and it keeps on calling till we reach the base case. Okay, like where x is 1 or x is 0 or x is something. Okay, so this is what we do in recursion. Okay, so basically DP is nothing but the advanced recursion. Okay, like why do I call it advanced? Because there is only one difference between DP and recursion, is that when we call the functions, let's say when I am calling fn x minus 1 from fn x, I don't store the value of fn x minus 1, okay, like in normal recursion. But in DP we store this value, so that let's say if there is another function called fy that also needs the value of fn x minus 1, we don't have to calculate it again. Okay, so DP is nothing but recursion. The only difference is that in DP we store the values of all the functions we are calculating. Clear till here, Tarun and Diptiman, Raj, Sakshi? Cool. So this is the only basic difference, that in DP we store the values so that we don't have to calculate it again. Okay. Now let's take the example of Fibonacci. Like we will understand the difference between recursion and backtracking. Okay. So let's say if I am calculating the fn of 5. So what we do in recursion, we call fn4 and fn3. fn4 again calls fn3 and fn2. fn3 calls fn2, fn1, and fn2 calls fn1 and fn0. Okay. Similarly 3 will call fn2, fn1. fn2 will call fn1 and fn0. Again fn2 here will call fn1 and fn0. Okay, so how many states we have called? 1 2 3 4 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay, so we have called 15 states, which is exponential, around 2 to the power n types. Okay, like 2 to the power n minus 1 you can say. Okay, like if I increase it to 5 to 6, it will increase exponentially. Okay, so in recursion, every time you are calculating these many states or these many function calls. Okay, so here the only difference you can state here is that we can save a lot of time and we can save a lot of I would say we can increase a lot of efficiency as well if we store the things we are calculating. So let's say if I store the value of fn5, if we store the value of fn4, if we store the value of fn3, so when we are storing the value of fn3, we don't have to calculate it twice. Like we have calculated it once here, second time we have calculated here. Okay, so if we store the value of fn3, we don't have to calculate it twice here. Okay, so we just have to calculate it only once. Okay, similarly, if I calculate it for fn2 and store it, so here I don't have to calculate again, here I don't have to calculate again the value of fn2. Okay, so we will be calculating only 5 states: fn5, fn4, fn3, fn2 and fn1 and fn0. Okay, these are the base cases, fn1 and fn0. Okay, so basically in DP we keep on storing the variables or the function values we are calculating so that we don't have to calculate it again. Okay, now like let's see that how it helps to reduce the time complexity. So let's say when you are not calculating the value of fn2 here. Okay, this one, okay, so just tell me, was the screen visible till now? Hello.
Yes, Anish. Yes, Anish.
Cool. Okay, so basically this fn2 when you are calculating, okay, you are not calculating the like the states below it again because you have already stored the value of fn2, so you are not calculating it again. So you have increased, or I would say reduced, the value of 2 to the power n minus 1 to n. Okay, like O of n you can say. Okay, so that's how, by storing the values of I would say sub problems or problems you are solving, and you are reusing them. Okay, and you are reusing them. Okay, so this is the basic fn like I would say basic intuition behind DP. Okay, so similar thing as DP recursion, we did it in the last session. What we did in recursion is that, what was the steps? First identify the base case, then identify the recurrence relation, okay, so these were the steps of recursion. If you see the YouTube videos, the only thing that will get added in DP is that store the values of every state. Okay, so let's say if I talk about recursion, let's say what will be the difference in the code part. So let's say this is int Fibonacci. Let's say I want to find the nth term. Okay, so I would call return fib n minus 1 plus fib n minus 2. Okay, so this is the recurrence relation, and base case is if n equal 0, return 1, and also like if n equal sorry, this is 1 and this is 2, return 1. Okay, so these are the base cases. Okay, so this is the recursion code. Okay, so how can we improve it to DP? It's very simple, we just store the values. Okay, so it will be same as this, that if int Fibonacci, we want to find the nth term. So before like doing all these parts, we first check that we have already calculated the value or not. Okay, so let's say we will check that if dp of n is present or not. So I'm writing the pseudocode here to make you understand. Okay, so if we have already calculated the nth term in some other or previous use cases, we will not calculate it again. So if dp of n is present, we return dp of n directly. Okay, otherwise we do the exact same thing. If n is equal 1, or let's say n is equal 2, we return 1, and before returning 1 we store the value of dpn. Okay, so let's say we store this one into the dp array. Okay, otherwise we update the value of dpn as Fibonacci of n minus 1 plus Fibonacci of n minus 2, and then we return dpn. Okay, so this part is the new thing, that we are storing dpn instead of directly returning, because so that we can reuse this value next time we need the nth term. Okay, so this is the main difference between recursion and dp. So dp is basically advanced recursion, or you can say a recursion where we store the values. Okay, clear till here? Hello.
Yes, Anish.
Others, like only Wasim is on. Like, am I audible like to everyone, right?
Yes.
Okay, cool. So let's see that what are the main steps in DP. Okay, so let's say the first step to identify whether a problem is from DP or not. Okay, this is, I would say, a personal observation which I have made over the years, is that, like, let's say when there is a problem where, like, it's very difficult to have a greedy algorithm, or let's say whether it's very difficult to know that which state will perform the best. Okay, so like when you see that brute force works the best. Okay, like when you see that calculating all the states or exploring all the options will give you the best answer, and optimizing that which state will give you a better answer is difficult, that is generally a DP solution. Okay, like where you have to explore all the states, explore all the states and combinations. Okay, like where you feel that you need to explore all the states or all the combinations to find out the perfect answer, that is generally a question of DP. Okay, so let's say there is a state called S1. Okay, so let's say S1 is dependent on S2 and S3. Okay, now S3 is again dependent on S4 and S5. Okay, now S2 is dependent on, let's say, S1 and S4. Okay, so when you see that a certain state is dependent on other sub problems, or let's say a state with a smaller input, so let's say if I give the input as x, so this state with input x depends on the state with input x by 2. Okay, and it also depends on the state of, let's say, x in let's say x by 3. Okay, so when you see that a certain state depends on substates, or let's say states with smaller inputs, okay, so then there is a high probability that it's also a DP problem. Okay, so these are some of the observations that you can make. Okay, now let's go to the next step, that what should be your strategy while solving a DP problem. Okay, first identify the states. Okay, like how many states I need to have. First of all, how many states, like whether it's a 1D DP or it's a 2D DP, how many states. Second of all, what will be those states. Okay, so let's take the example of knapsack. Okay, so in knapsack, what variables do we have? One variable we have that we have a particular weight capacity, that our weight is limited. Second of all is the number of items we can have. Okay, third of all, like what we have is that uh, value of every item, right? So to identify the states, the first step is to identify the number of variables you have. So first identify the variables in the problem. Okay, so in knapsack these are the three variables. Okay, now after identifying the variables, think that which, like if I fix, let's say, weight and number of items. Okay, so let's say if I fix number of items and weight, can I control the value of the item? Okay, so think in this manner, that what states or what variables do I need to fix so that I can control the output. Okay, so this is the thought process, that what variables I need to fix. Let's say think in like this way, that if I know the value of these variables, can I get the output? So let's say there are variables x, y, p, q, r in the question. Okay, so think like this, that out of these 5 variables, if I know the value of, let's say, x and y, can I calculate the output? Okay, or let's say the which means the values of which variables can help me to know the output. Okay, like this part is clear, that how you should fix the states. Hello. Cool.
Yes.
So ऐसे सोचना है कि like what variables should I fix so that I can calculate the value of the output. Like if someone comes to me and tells me the value of this and this, can I calculate the value of the output? Okay, so let's say if someone comes to me and tells me the value of x, y, p, can I get the value of the output? Okay, so this is how you I would say identify or fix the states. Okay, now let's say, okay, I think let's shift to Google Meet. I think the free time for it is over. Sorry for the inconvenience. I am just giving you a Google Meet link, just join it once. Okay,